Welcome to the notes on solving systems of equations by substitution. We'll learn what that is in 1 sec. Remember, system of equations can have three possible outcomes. They could have one solution. Remember, that's an ordered pair. We talk about solving by graphing. It's the point of intersection. So we know that there's one solution. We know that there could be no solutions. That's when you get something where you get some number and it's not equal to another number. So maybe you're solving it and you get something where you get 2 equals 3. Well, 2 does not equal 3, so that would be an example of no solution. Then we have infinite solutions where some number equals itself. So maybe you're solving it and you get left with 4 equals 4. Well, that's always true, so that would be infinite solution. So keep that in mind when we're solving these. So now, how do we solve by substitution? The first thing you're going to do is I want you guys to make a T-chart. Okay, and again, this just is a visual, helps you organize. You'll see why in a second. Now, you're going to be given 2 equations. All right, one of the equations, one of the variables will already be by itself or will be very easily be able to solve to get by itself. That one you want to write on the left. So in this case, we're going to write y equals x minus 4 because y is already by itself. And then on the other side, we'll write the other equation, 2x plus y equals 5. Now, why do we call it the substitution method? Because we know that y equals x minus 4. That's what y equals. So where I see a y, I'm going to substitute that value in, and then we'll solve it. So here we go. 2x plus y, but we know that y is x minus 4, so I'm going to substitute that in. Remember, always use those parentheses when you substitute, and you'll see why very shortly. So now once we've done that, now we just solve the equation for x. So we rewrite 2x plus x minus 4. I didn't have to really distribute anything there. And then that equals 5. Now it becomes a simple algebra problem. I'm going to combine my like terms. So I get 3x minus 4 equals 5. Since that's a minus 4, I know I need to add 4 to each side. So I get 3x equals 9. Then I know I'm going to divide each side by 3. So x equals 3. So you got x. You're not done. You're then going to substitute that back into this equation for x and solve for y. So you're going to have to do the substitution. You actually substitute twice. That's why we call it the substitution technique. So we're going to say y equals, well, we know that x is 3, and then we're going to subtract the minus 4. So then y equals 3 minus 4 is negative 1. So there's our y value. So that would be the point of the graph where they intersect. So remember, write your answer as an ordered pair. So 3, negative 1. That is your solution to this problem. Let's take a look at a couple more. Maybe we'll get one with an infinite solution, one with a no solution. So first thing we do, we make our T-chart. Okay, now, neither equation is solved for y or x, but I can see that this one could very easily be manipulated. I can just subtract 2x, subtract 2x. Remember, one of the equations, you got to get y or x by itself. So when I rewrite that, I'm going to get y equals 3 minus 2x. You don't have to put it in slope-intercept form. Just get y by itself. Then on the other side, I'll write my other equation. 4x plus 2y equals 6. Well, we know that y is 3 minus 2x, so I'm going to plug that in where I see a y. Let's do that. 4x plus 2 times y. Well, y is 3 minus 2x, and that's going to equal 6. So here we can see why those parentheses are important. We're going to have to distribute. So we're going to get 4x plus 2 times 3 is 6. And then that's minus 2 times minus 2x is minus 4x. And that's going to equal 6. So now we solve. 4x minus 4x. Okay, that actually cancels out. That's going to be 0. So we're left with 6 equals 6. Uh-oh, there we go. There's an example where a number equals itself. There are no more variables. So this would be an example then of, we would just write infinite solutions. And if I got these equations into slope-intercept form, you'd see that they'd be the exact same line. So you're done. That's infinite solutions. Let's take a look at one more. First thing we do is, again, I would make that T-chart. Okay, now again, neither equation is solved for an x or y, but again, I can see this one right here. I could just subtract y to the other side, and I could have x by itself. So I'm going to have x equals 6 minus y. And then on the other side, I'll write my other equation. 2x plus 2y equals 16. Again, we know what x is, so whenever I see an x, I'm going to plug in that value or substitute it in. So 2 times x, x we said was 6 minus y. And then we'll write the rest of the equation. Plus 2y equals 16. Make sure to distribute again. That's why we got those parentheses. So we're going to have 2 times 6 is 12 minus 2y. Then we have our plus 2y equals 16. Well, minus 2y plus 2y, that cancels, that's 0y. So we're left with 12 equals 16. We've got no more variables. Uh-oh, this is what we talk about. 12 does not equal 16. Never. So this would be an example then. We're done right there where this would be a no solution. And if I put these into slope-intercept form, they would be parallel lines. So there you have your notes on the substitution method. You've seen what no solution, infinite solution, and what one solution would look like.